This video is for Chemistry in the Earth System, Unit 2.1, Parts of the Atom. Today's essential question: how can the quantity of protons, neutrons, and electrons in an atom be determined? Our first main idea: counting protons, neutrons, and electrons. The atomic number of an element equals the number of protons in the nucleus of the element's atoms. Every element has a different atomic number because the element's atoms contain different numbers of protons. The number of electrons in a neutral atom equals the number of protons in the atom's nucleus. In other words, in addition to describing the number of protons in the atom, the atomic number also describes the number of electrons in a neutral atom. Notice, only a neutral atom. This will not apply to any ion. Therefore, if the atom has lost or gained any electrons, this will not apply. Recall from a previous lesson that each proton and neutron have a mass of about 1 AMU. Because the electrons in the electron cloud have very little mass, the entire mass of the atom can be considered to be equal to the mass of the protons and neutrons in the nucleus. A neutral atom of carbon, for example, has 6 protons and 6 neutrons, each with a mass of 1 AMU. The approximate mass of the stable carbon atom is therefore 12 AMU. This atom has a mass number of 12. The mass number expresses the total number of particles in the nucleus of an atom. Because protons and neutrons are always present in their entirety, meaning not like a fraction of each, the mass number is always a whole number. The table that you see on your screen here shows the atomic number and mass number of various common elements in their stable states. Note that the numbers of protons and neutrons are not always equal. If the mass number for an element is given, the number of neutrons in its atoms can be calculated by subtracting the atomic number from the mass number. Remember, mass number minus atomic number is equal to number of neutrons. Gold 197 has a mass number of 197 and an atomic number of 79, which means it has 118 neutrons in the nucleus of the atom, because 197 minus 79 is equal to 118. Hydrogen 1 has an atomic number of 1 and a mass number of 1. So the number of neutrons in a hydrogen atom is calculated to be 0. Hydrogen is the only element with atoms that contain no neutrons in the stable state. The atomic number and mass number are used in the symbols that represent the isotopes of the elements using the form on the screen here. X super A sub Z. Here, X represents any element. Z represents the atomic number for the isotope, and A represents the mass number. For example, the isotope gold 196 would be represented by the following symbol on your screen here: AU super 196 sub 79. The symbols for other isotopes of gold would have the same atomic number but different mass numbers. At this point, you should be able to generate a full and appropriate response to today's essential question: how can the quantity of protons, neutrons, and electrons in an atom be determined?